Hello and welcome friends. I hope you are enjoying the videos and proof of the theorems of, of different mathematics branches. Here once again I am came with new idea of number theory, that is congruences. We will see what is meant by congruences and examples of congruences. The definition of congruence is, if n is a fixed positive integers, then two integers a and b are said to be congruent modulo n, and it is symbolized as, you can see this is a symbol for use for congruences, a congruent to b modulo n. We read it as a congruent to b modulo n. If n what is the definition? If n divides the difference a minus b, that is provided that a minus b equal to kn for some integer k, then we said that a congruent to b modulo n. So this is the definition of congruences. For example, we know that 3 is congruent to 24 modulo 7. Since if we take the difference of 3 and 24, we have minus 21, and minus 21 is divisible by 7. It will gives us minus 3 into 7, and therefore 3 is congruent to 24 modulo 7. If we have 15 and 13, if we have two numbers, then we can see that 15 is congruent to 13 modulo 2. Since this 15 minus 13 equal to 2, and it is a divisible by 2. 2 is divisible by 2. It gives us 2 equal to 1 into 2. Again, if we take 20 and 8 simple examples, then you can see that 20 minus 8 which is 12, and 12 is divisible by 3. So 12 is equal to 4 into 3. This means that 20 is congruences to 8 modulo 3. So this is, we can see that in this way we have the definition. If these for any two integers a and b, if the difference is divisible by n, then it is called as, their two integers are called as a congruent to b modulo n. If we generalize this, for example, if we have any general integers a, any integer a, then we know that by division algorithm there is a quotient and remainder. A equal to q into n plus r. So this implies that a minus r is equal to q into n. Q is integer. If there exists an integer, this means that a congruences to r modulo n. Okay, then you can see that this r is a remainder. What is my r? R is a remainder when a is divided by n, but the value of r, the different reminders are for n 0, 1, 2 up to n minus 1. These are the different reminders we have when we divide any number by a. For example, if you take 5 and let us take a number 21, When we divide this 21 by 5, we get quotient 4 and remainder 1. If we take another integer, if we divide 22 by 5, what we get? We get quotient 4 and remainder 2. Again 23, we get 4 and remainder 3. 24, we get 4 and remainder 4. 25, we get remainder 0. So this is the these are the different remainder when we divide any number by 5. Again let us say if we take 26, we will have remainder 1. So the remainder are repeated. The remainder is a fixed set. Remainder of 5's when we divided we have 0, 1, 2, 3 and 4. Hence for any integer n, we have the set of remainder 0, 1, 2 up to n minus 1, and this set of remainder is called as a least non-negative residues. This called as a non-negative residues modulo n, or this is also called as a complete system of residues. It is also called as complete system of residues. Okay friends, so easily we can see that we can obtain the complete residue system of any number. Okay, so can you guess about a residue system of 9? That is 0, 1, 2, 3, 4, 5, 6, 7 and 8. This is the complete residue system of a number 9. Right. Now let us move an important theorem on this congruences. I will write the statement of this theorem. For arbitrary integers, a and b, comma, a congruent to b modulo n, it is given if and only if a and b leave the same remainder, will lose the same remainder when divided by n. Okay, so what is given is, so first suppose that, let us prove this. Proof is very simple. If first we take a congruent to b modulo n, and we will show that they leave the same remainder. Okay, then apply the definition. That means n divides a minus b, or in other word, there exists an integer k such that a minus b is equal to k into n, or a equal to b plus k into n. Now we can apply division algorithm. This number b, when we divide by n, this gives us a quotient and a remainder. That means we have b is equal to q into n plus remainder r. So let us put this value here. We have a equal to, what is b? Q n plus r plus k into n. Look at this, we can take n common. We have q plus k into n plus remainder r. Now this is my remainder r. Okay, so what is here r? R is a remainder when we divide this b by n, and here we will get the same remainder when we divide a by n. Okay, so whenever a is congruent to b modulo n, these two number will leave same remainder. Now conversely, suppose that a equal to k1 n plus r and b equal to k2 n plus r. That means this a and b will gives us a same remainder. Okay, now a minus b equal to k1 r k1 n plus r minus k2 n minus r plus r will be cancelled, and we have k1 minus k2 into n. This implies that n is a divisor of a minus b, and when n is a divisor of a minus b, we can say that a is congruent to b modulo n. So whenever two integers a and b will leave the same remainder, then a is congruent to b modulo n.
Hello guys, thank you for watching video.